Hi everyone and welcome to the Golang Index number 3. Today we are going to learn about variable declaration and data types. So without wasting our time, let's go to the data type and variable and declaration. Let's open this link and also this one and also the last one. So we're going to open these three tabs. So this one is a go by example, so they just give you an example. This one they talk about go variables, and we have here the two that guide us. So let's see. Sorry for my internet. So let's start with this one from W3 School. They say variables are container for storing data values. So if you need to store any value, we need a variable. So in Go, there are different types of variable. For example, int store integers such as 1, 2, 3, -1, 2, 3. Float store the floating point number and with a decimal such as 19.99 or negative 19.99. We have a string, we have a boolean. So string stores text, boolean store to state true or false. So to declare a variable in Go, there are two ways to declare a variable. So the first one is in var, another one is using this double colon equal sign. So that's two ways to declare a variable. Use var keyword followed by variable name and data type. So you use var and then variable name and then type and then value. So it put the value at the end. And with double colon equal sign, you just only need the variable name and then value. So in this case, the type is inferred. So they take a look of what is the value, what type of this value, and then they just infer it. So they go automatically try to determine which type is going to be there. So it means it's a compiler who decide what the type of what is the type of value of variable name. So variable declaration with the initial value. So since we have this, here they just show us like if you come here on the tool of Go, they just have this online editor where you can put the things. So for example, they provide this, so they declare two variables, C, Python, Java, and they put the type. So as you have seen, we just put var and then variable names and then the data type. So this one is Boolean, so I don't know what's the default value of C in Python and Java, but it might be true or false. So I guess it might be false, like default value might be false. So let's just do yeah, you see that the default value of C, Python, and Java is for C, Python, Java, and C, Python, and Java is the false, and we declare an I, which is an I which is an int. So the int by default is equal to 0. So if you don't provide a value, it's going to be 0. Oh, that's interesting. That's very nice. So let's see if we can do like another kind of thing. So let's say like let's declare var now, then let's make it 3, and let's come here instead of declaring an I, so let's remove that and let's print it now. So like this way. Now let's run this, see if we get a 3. Okay, as you can see we get a 3, so we can declare var now, and then as you can see right now I didn't put the value, so because I didn't put data type, I didn't put data type. So since I didn't put data type, the Go is trying to automatically determine the inf. It's going to try to know the type of these three, and then it's going to be automatically given to these now. So that's quite interesting. So if I want, I can give it int. So and then I can run like this way. So if I do run, you see that I get a 3. So if I want, I can make it a float as we have seen, and I can run undefined float. The data type of float, does it exist? Let me see. Add a proton here. So float 32. It's float 32, not float only. So let's just do run, and yeah, you see that it's a 3 because I did put float 32. It just 3. So that's how we declare variables. So let's see. The thing which is surprisingly with this declaration using this syntax is that um, it is not possible to declare it without giving it a value. So that's the first thing. And oh, let's see. I think I know. Okay, if you come here, the in Go variables that is explicitly declared and used by compiler check value. The var declare one or more variables, so you can use var to declare one or more variable. As you have seen lastly, we had C, we had Java and Python. So and we were able to just declare them at the same time and then give them the value. So that's quite interesting, and so we can go with infer the type of initialized variable. So if you declare a variable and then you initialize, so the Go will try to determine the data type of a given variable. So for example, here A, we didn't put like it's a string, so because we used equal to initial, this one will be inverted to string. So the Go declared without a corresponding initialization are zero valued. For example, zero value for int is 0. So it means for an A, so if you declare variables and then you don't give anything, by default it's going to be it's not going to be like null or undefined like it used to be in JavaScript. So but it will be zero valued. So if this int is going to be a 0. So if it is a string, maybe I don't know the zero value of string, but I think it is like an empty string. So we will see that. So and this syntax, we can also use this syntax to declare and initialize the variables. So and the thing, this syntax is already available inside the function. So it means the syntax of declaring the variable. So if for example if you don't want to provide var and then we just say now and then we do like this, I don't know if this is going to work inside or outside of the function. So this is not going to work unless you're in function. So if I move this down to here, so it's going to be it's going to work. Yeah, so that's how we do variables. So since you have seen like a little basic on how you do variables, I think we can just jump from here and then we go to let me just say take this one and okay, so let's wait for updating the progress. So let's go through the data types. So we are going to see all these data types. So where we start, so let's go to the two basics and this one. So I'm going to close this one and this one and this one. Now for this one, so I'm going to try to use I'm going to use a terminal. So that's what I'm going to use. Or let me just do exit and go to the folder that we use, which is 1 days of school, and which so we are still going to use hello, the package of hello. Oh, let's create another one. So instead of using hello, let's create another which we are going to call variables and data types. So this is what I'm going to use, and I'm going to go into variables, data types, this one. Okay, now we have this one. So what we have to do is make sure that we initialize the model. So we are going to say go mode init, and it's going to be let me just name it I don't know the naming convention for this, but let's use this one. Okay. So we do go mode init and then we provide the name, which is going to be github.com/ let's say Roger, and then it's going to be variable data types. So let me see if it's going to allow this one. Okay, I guess it just works. Yeah, it's working, man. Now let's open up this one. Now you see that we have this one which just has a variable in data type, so that's nice. Let's create a new file and then we're going to call it variables. Oh man, variables.go. And so normally we have seen that we give first a package. So I don't know the naming convention for names. I see that. Go package names conversion. So let's see what are we going to get here. So let's see. Let's before we can do let's see how do we have to give the package names. So I think this is going to take some of the time. So this is where they have the tool. So they have here the basic types for before we see how we define the package. I'm going to use main. So and I think I make a video for how we can name, and we have seen that so we need to have main function, and we can just come here and then do everything that we have here. So expected declaration. So let's import font. We do this vmt, and we can come here. So we can do vmt dot print and hello what. So we are going to have a number. So a simple number num, which is an int, is going to be 3, and we are going to try to print now. So actually we don't need this one, we don't need semicolon. So we also don't need this semicolon here. Let me just save this one. So they're saying expected declaration. So how do we define? So we use func. The func, not fun. Man. Sorry for that. Func, not func. Fun. Yeah. Sorry for that. Let's just save this one. As you can see now, it just running. Now let's see if we can run this one. So I'm going to run this one using variables. Let's go. You can see that it just displayed 3. This is nice. We have a face program that we have. So currently they're saying that it is possible that we can omit this one. So so if you want, you can do this, and it just runs. And now they just formatted it because we didn't provide the value, so they just say it's better if you use this one. But if I try to move this one up, it's going to be this one need to be inside the function. So if you use this syntax, it will be inside the function. So what you can do, you can just save now, and then you can just get rid of this, and now it's going to run. If I do go run variables, it's going to wait a while. If I don't put go, no, it's not going to run. Go run variables. Let's go. You see now I get a 3. So that's nice. And we are going to start with the first data type, which if you're interested in running Golang, so this is look like a long article. So I don't know how long we can go through this, but Golang is a statically types. Let's start with basic. If you're interested in running Golang, then we have a Golang comprehensive tutorial for you. So they have a tutorial Golang by example. So I think we can take a look on that. So after, so I'm not going to go through this. Now let's see the current tutorial. Below is the table of content. Now we are going to see the overview, the basic type, integer, float, complex number, byte, room, string, boolean, and then we have the composite type, non-difference type, array, struct, and the reference types, rise, channels, map, and point. So basically we are going to run the basic types. So that's what we are going to run. So so let's start with the basic types. So we have integers, they can be signed and unsigned. So this one, signed, means they can have positive number and negative number. So by default, int, so int is platform dependent, means the value of int, it can depends on the platform. So if you want the size, so I don't know, like the size of the value of int, so let me start. Let me just put it like 256. Does it work? Yeah, it works. Oh, yes, I didn't put it like, I need to put like int. Yeah, it works. So for the int 260, 56, it is working. So let's start with like int 8. So if I do, I put it like int 8, or let me do undo int 8 like this way. So normally you are going to see that I gave this error. So the reason why I gave this error is because for the size of like 2 bits, so yeah, I think it's 8 bits. The size of 8 bits can store 2 power 8 minus 1, so which will be 128. So if it can store up to, oh, it's not like this. Oh, it's 255. It's 255. Sorry for that. So and it's not going to be like minus 1. So it's going to be 200. It's going to be on 256. So it can store the value from 0 up to 255, or you can store 256 values. So it means if you include 0, it's going to be 256. But the maximum value which you can hold is from 0 up to negative. If you become sign, they take 256 and then they divide by 2. So if you divide by 2, you are going to get 128. So it means we can have from negative, we can have negative 128 to the positive, which can be up to 127. So it means for this work, I need to make sure that this, because it's int 8, I need to make sure that it is 127. So let me change undo. Change word 127 and then save. Now you can see that it can just run once. So let me just show you. Hold on. Variables like this way. You see now it runs. But if I change this to 8, it's going to throw an error. So the reason why it's going to throw an error is because we start from 0 up to 127. So we start from 0 up to 127, and the negatives start from 1 up to negative 128. So if I run this, it's not going to run. So as you can see, they are just showing me an error. So let me just show okay, as you can see, we just have this error. We cannot use 128 in an int of 8. So but if we try like add the negative here, so it's going to run. So if I do 129, it's going to have an error because you need to go up to 128. So this is int 8 bits, int, and then with the size of 8 bit. So another one of the things that you can just put, like, it's going to be unsigned. So let's try with 16. So if you go back here, we can see that we have 16. So we can have 16, and so for the 16, so we can have up to can have up to, so it will be up to, can have up to 2 power to be 2 power 16, which is going to be 656. Okay, that's how it's going to be. So this is how it can be, and then we divide this by 2, so we can divide by 2, and it's going to be this one. So the maximum value that we can contain to be 1 2 7 6 8. So but since this one is in a positive side, we need to remove 1 to 1, so we cannot get up to 32 7 6 2 7, like this way. So that's the maximum value for this one. And for the negative, we can just insert negative here, and then it's going to be 8. So if I put 9, it's going to throw an error. So that's how it is. For the int 32, in 32 it will be the maximum value will be 32. So let's see how it equals, how it is. Value of that is going to be it's 4 millions. Is it 4 millions? It's 4 billion. So if we divide by 2, we are going to get this one. So it means the maximum value that we can have, it's going to be this one. So the maximum value that we can have, it will be this one. In the positive side, it's this one, and then minus 1, so which is going to be 7, and for the negative, so it's going to be 8, so it's going to be like this one. And if I add 9, it's going to throw an error. So for the 64, so it's the same. Let's just do this one and then group them. So 64, and it's gonna be this one. So I don't know if it is, so 1 2, I don't know if it is a 0, I don't know. So but that's the maximum value that we can get. So we divide by 2, and then we see like the value for that. So this will be like on a positive side and negative side. So that's how it is. So you can just save int, which is 8-bit, 16-bit, 32-bit, and 64 bits. Okay, so here they say that on the 32-bit machine, the size of an int will be 32 bits or 4 bytes. So if you have a 32-bit machine, the size is going to be 32 bits. So if you are on 64-bit machine, the int will be this one, which is 64 bits or 8 bytes. So that will be the size of an int. So if you use an int, so if necessary, if you want to do like to minimize like the memory size, maybe you can use like, if it is not going to contain a lot of numbers, so it's better to use smaller numbers. So that's how it is. Now so if you don't provide any value here, so it will be invalid as int. So and if you're on 64-bit machine, it's going to be 64 bits, and if you are on 32-bit machine, it's going to be 32-bit machine. So let me just come here and then I comment this one, and I guess I need to make sure that this is like 8. So that's how it's going to work. So so I think they are showing a lot of things here. So let's see. So the range again, platform dependent on 32-bit machine, so it will be the same there. That's what I say. The range to be 2 power 31 to 2 power 31 minus 1. So So it is a good idea. So for the range, we also might remove one bit. So I don't know why we remove one bit. So it's a good idea to use int whenever using whenever using the signed integer other than case mentioned below. When a machine is 32-bit, the range is greater than 2. And then use int 64 instead of int. So if you are on 32-bit machine and then you want the value which is greater than this range, so it is better to use int 64. Note that in this case that two 32-bit memory address the form 64-bit together. So it means to store this value, so then we need to have two address memories to address two 32-bit memory. So to store this value in 32-bit. So this is how we declare variable. We declare var a int. So if it is on 32-bit int, it's going to be 32 bits. If it is on 64, it's going to be 64 bits. So int is a default type for integer. When you don't specify the type, the default will be int. So if you don't specify if you don't specify the type, so it's like this way, it's going to be an int. So format.print reflect. Okay. So bits bucket of Golang can help us to know the size of an int on your system. So bits package. So bits package of Golang. So I don't know how we import that. Yeah, we import the bits. So we say like size of int in a bit. So it's going to be bit.uint size. .ui int size. UI int size. So the unsafe size of function can be used to see the size of int in bytes. Okay. So we can import unsafe and then we can say unsafe size of a. So that's how we can determine the size of. And so as you can see, so this printf has these decorators. I think if you have used the C, you know like this is like one way they display like a variable. If it is a digit, so you can just use digit. If it is a string, then you can use s. That's how it is. I didn't know that can work. So for example, if you want, we can come here and then we can do this and we can say we use the ampersand, and because it's going to be a number, so it's going to be digit, is the minimum negative number for it's not like that's one is not like the minimum, so the minimum it's minimum for 16 bits. So we can just do this way. For int 16, I guess. So let me hope that I'm right. So cannot use as a constant value. So that's quite interesting. Let me see what's happening. Value int. Cannot use a var. Let me just. It's better if we move it a bit down here and. Okay, let me just do this and see there. So go on variables. Let's go. Say cannot use variable as. Cannot use as untyped int constant as int is a variable declaration. Interesting. Okay. What's the issue? I don't know the issue by now. So let's see. I guess tube 16 equals. We can see that this is the maximum value of 32. So sorry for that. My mathematics, I don't know why. it's just broken. And here, so we had 8, so this is the minimum value for 32. So, and they're saying that can we the let me see if I do run this one. So go run variables like this way, and oh, it just says D. So how did they do that? So they used the ampersand D, and they passed the what did they say? The possible formatting. Oh, so if you want to use that, you use F. So I didn't know that. Oh man. Let's just save this one and let's do go around variables. Yeah, now you see. So if you want to use the formatting from the C directive, so you can use printf instead of print line, and then whenever when it is possible, you can just add you can have the new line at the bottom, so at the end of the line. So that's quite interesting. We have, so right now we see that you can do print line, and then you can print format, so where you can add formatting. So that's quite interesting. Let's go. So I think we have saw about the int, and so let's come here. So I want to see. So then it is possible that we can determine the size of this using the unsafe. So you can just do unsafe and like this way, and unsafe can determine like the size of this, and I don't know if they and the size is, and then it's only the, I don't know if it's a string, so but I'm just going to just oh, I forgot, we don't put this here, so so we can have now, so it's going to be unsafe like this way, dot size of, and then we can just put the numbers like this way, and then we can save, and then we can go run variables like this way. You can see the size is 4. Yeah, it's bytes, so they are giving you the size in 4. So we can just, it's 4 bytes. So 4 bytes is equal to 8 times 4 bits. So let's do bytes like this way. So to make it easy, very, very easy to be understood by everyone. So let's do this with this, go around variables like this way, and we can see that's 4 bytes. So that's quite interesting. So you can use unsafe to determine the size of, or you can use these. Okay, let's go down. We have int 64. We saw that, and we have unsigned int. So for what we did, so if you want, you can just make this unsigned if it's not going to have the negative side. So you can just save it be a positive, and when it is positive, it means so when it is positive means it's going to use the value up to, wait, why isn't it not giving me like the, okay, let me use this one. So it's 2 power 32. I guess it's 4 million like this way. Let me just copy this one to clipboard, and okay, they just give me that now. I don't know why this compiler is going like that. So let me yank this one and come here, then we okay, and then P. So, and because we are starting from 0, we need to make sure that this is 5. Yeah. So So it means if you want to use negative side, you can put a u in the front of any integer that we have, from uint, uint 16, uint 32, uint 64. So that's how it is, and so that's how we use unsigned. And then we have also the float. So the float can be float 32 and float 60. So right now, if I try to use like .2, so it's going to throw an error. So because it's not, this one is not float. So let me just use a float 32, like this way. Now you see that's a float, and this one is going to throw an error. They're going to say, you guy, you need to change this. You know the digit, it's a float. I guess they said they use a f, it's a float, and I can do run, like go run variables, and yeah, we see that. Is it working? Is it working? Go run. I'm getting like variables. Let's go. Oh, I think I it's not running very well. So let me see variables. You see, you just have 6. It was rounded. Oh, this one I even need to change. I don't know how this was. So float 32. Let me see. So the way they do that. So if you want, we can. So we used to say float, and then the track one. Let me save. Let me. I don't remember very well how they do that. Go on variables and go. Oh, they just add 1, 0, 1. Oh, I don't know how we do that, but you see that just being rounded. So let me have like 42, which is going to be just run this, go run variables like this way. You see that it just has 2 now, and it's adding 1. Oh, I don't know. This is very interesting. So the floats, so that's how you declare the floats, and you can give it 64 size. And so if you want, you can name it. So if you want, so you cannot say like float 64 by default. If you put a number and then it's a float, it's going to be 64 by default. So that's how you can use it, even the floats. So let me say this one, and also let me go on variables, so like this way. So you see now it just runs. Sorry for the naming, so it's not working so as expected. So we have the floats, and also we can have a complex numbers. So complex numbers. Do we have there complex numbers? Yeah. So we have seen int. We have seen the float, and also we need to have a run. What is about run? So actually the run is so I think run. So let me see, what is the run? Find run. So yeah. So it's below this one. So we can have a complex where we can have imaginary part, and imaginary part of float 32. Oh, we have a complex. So let me just do this one. So we can have. So we saw that this is a. Let me just do make comment. So actually, I'm going to remove this and save. Okay, so so we're gonna have it's not going to, so we're gonna have a, which is a complex, and it's gonna be complex 64, and we can just say complex. So we can say complex, and then we provide the imaginary part and the real parts. So I don't know where we need the complex, but I think we can also run that. So we say a, we are a, so using the complex function below, do make sure that both a and b should be the same type. So this a and b need to be the same type. So if I pray like 2 3, I guess this one is going to, okay, now we can just print, we can do format the print line, and then let me see if I can print a like this way. It works. Let me do colon variables, oh, it's not working. Colon variables this way. You see that I just display 2 rank 3 high. So this is the imaginary part and then the real part. I guess that's how it is. Yes, both signature. So I think today's video is long, but I think we have that. So we can also have, so if you use a complex 64, it means both the real part and imaginary part are going to be 32. So if we say var a b, and then we just make it like complex 128, and then we say it's going to be complex 128, and so we can have 12 and 5, and then we can format and then print line, and it's going to be b. So we can so if you want, you can omit that one, but I'm not going to omit it. So let me do colon and then variables. So like this way, you see now it has the complex. So this one means that if you try to see the size of this one, it can be, this one is going to be 64 bits, and also this one is going to be 64 bit. Both the imaginary and the real parts is going to be 64 bits. Yeah, so that's how it is, and so that's how you can use a float. And we have also bytes. So the bytes is the same as uint. So if we say like a byte, it's an alias. So byte a is going to be, so byte cannot contain negative, so it can be from 0 up to 155, like that case. That's how it can be. We already have bit. Let me just I look at how I declare these things. So we do var, we do var, and then we put let's call this byte c, and we can just put like this way, and we have to put the value of byte, and we can print format this one. So we print this one. If I want, I can have a comma, and then I can print c like this way, and if I want, I can move this up, and let me just print even abc like this one, and then put b here at the bottom, and let me tree this one. Let me just save, and let me run this colon variables. You see now it just runs, and this is the bytes. So the bytes same as the byte is the same as u. Let me just, okay, so this one is alias for uint like this way. And if I do room, so, and I saw that If you come on the bottom, you see that the room is also an alias for 32. So if I say room D and I say it's going to, oh, it's not going to be, it's going to be var D, which is a room, and it's going to be so like this way, and to be the alias for that one. And if I want, I can come here and then I display this one. I'm save frame and UTF. Yeah, normally the rune is an alias for int. The integer variable is meant to represent the Unicode code point. To understand the rune, you have to know what is a Unicode. So rune, it's used to represent the Unicode. Beyond that short description, what you can refer to the former's blog about it. So okay, so this is quite amazing. So I'm going to see if I can read these articles after. So I think we learned about loon, we learned about float, byte, boolean. We haven't seen boolean. So boolean, we have seen that we can just say var is okay. Okay, we can have E, so I don't know how I'm gonna call it, and then we can give it the boolean. But the boolean can have false, it can also have true. So if you don't provide it, it's just going to be false. If you don't provide it, like say the current variable here, and then you have it here, E, so it's going to be boolean. By default, it's going to be false. So if I want, I can just save this one, and I can do run this one. So let me to go run variables. Okay. Oh, I don't know what I'm doing, but go run variables like this one. You see now it's just false. So if I want, I can just make this one true. So like this way, and I can go run variables like this way. You see now it's just true. Okay. And so what is UI into PTR? So is it a pointer? So this guy talks about the Unicode. So I think we read this articles after. So we learned a lot about variables. So right now, so let's go back here and see what else haven't we looked at. So I think it's pointers, UI into pointers. So let me see if I can view this. Oh, I was UI int PTR. This is undecided that is larger enough to hold any pointer address. Therefore, the size and range are platform dependent. Yes. So it's also platform dependent. So it means on a 32-bit machine, the size of int will be 32-bit or 4 bytes. That's quite interesting. So I think okay. I will just make a video about it. So I was questioning myself about but so on 32-bit machine, the size is 32-bit or 4 bytes. On 64 bits, the size of int will be 64-bit or 8 byte. The range is also platform dependent. So this is UI int pointer. What is UI int can be converted to unsafe pointer, vice versa. So you can just the UI int, it can be converted to the I pointer. So its purpose to be used along with unsafe. The pointer may be usually used for unsafe memory access. So it means we can use UI int pointer when we want to use the memory, when we want to access the memory. When you want to save the pointer address for printing it or storing it, since the address you just stored does not reference anything, the corresponding object can be garbage collected. So this is what I did. So I think this example currently might not be understandable, but so I think this one, because this one is used whenever we want to use the pointers. So we want to access the memory using the pointer. So it means we say this is the address for this memory, and whenever we want it, so we will use these variables to know like which is the memory it is accessing. So I think that's mostly it. So I think that's mostly if for the next time we'll be going through conditions, functions. We go to conditions, for ranges, if, and errors. So we go through conditions, and then this one, and then we are going to go functions, multiple named returns. So that's what we go next. So thank you for watching this video. So